Algebra 2, what's up, guys? Hey, I was just informed that the video that I posted for section 8 only had me. And I'm sure as much as all you want to see is me, you really need to see the actual notes that go along with it. So let's make sure that we can see those notes. So we're going to do a quick redo of this video for section 8. All right, so section 8, exploring transformations, page 59. You guys can see right there are 5 key terms. So you got to make sure that you find all key terms. They're always listed on the first page, 59, but then you got to find them throughout the section. They're highlighted in yellow. Key parts, 3 charts. Those are really, really important for you guys to understand. Copy those down, get those into your notes. Remember, you can use 1 page of notes on your test, and you got to make sure that it is your handwritten notes. There's no typing, there's no photocopying, there's no someone else doing it in their handwriting. It's only you. Okay, and then I give you the 3 pages that you can find those 3 charts on right next to it. So these examples, as you'll see, they're very conceptual, meaning it's all about learning the concept, because the actual arithmetic is minimal, and the you writing your answer part, that's minimal. It's all about just getting the concept. Okay, so let's jump into one of those concepts right here. Translations, that's literally moving a graph. You're not, like flipping. You're literally taking a point and moving it left or right, up or down. If you move it left, that means you are subtracting from the original x. Okay, if you move it right, you're adding to the original x. If you go down, you are subtracting from the original y. If you go up, you're adding to the original y. So that's what that little part right there means. The reflections right here, okay? So if you are reflecting it over x, you will only change the y value, okay? So if you, again, are reflecting it over the x, you are only going to change the original y. That means that the original x does not change, okay? If you reflect it over y, you are only changing x. All right, so you're going to see what this looks like when it comes to example problems. So let's take a look at these examples here. This is the intro. We're doing 1A and 1B, which are on page 59, so you should be tracking with me. I give you the original point. By the way, again, since I've already filmed this video, my apologies. For whatever reason, it didn't connect. All the work is already done. Okay, so what is written in black is the original problem. Blue and red and potentially green is the add-on stuff. Okay, the work. All right, so original point, -1, 3. Then just so we always remember, x goes first, y goes second. For 1a, it says 4 to the right. Okay, so what do we do if we're moving left or right? We only change the x value. The y value does not change. Okay, so you can see that we have, let's get a different color here. You can see that the original y value right here does not change because it's still the same down here in our answer, but the x value changes. So the original x is -1. We add 4 to it because 4 to the right means add, and you get 3. Brand new point, 3, 3. Okay, 1b. This is a double translation. We have a 1 to the left, which would mean subtract 1 from x. And then we have a 2 down, which means subtract 2 from y. Okay, so the x situation is right here. Okay, and the y is happening right here. So we have an original -1x. We subtract 1, we get -2. That's going to be our new x value. We have an original +3 for y, but we subtract 2, giving us a brand new y value of +1. Okay. All right. Let's move in here. All right. Original graph. I'm giving you the original graph. Looks like a little check or a little V. And the green points off to the right-hand side there, those are all the original points. I just wanted to save time. Okay, so I'm giving you the original points so that you can understand that that's what we're manipulating. Okay, don't worry about the red part quite yet. So for 2a, they say you have to regraph it, and you have to translate every original point 3 to the right. So again, that just means take every x, add 3 to it. Don't change the y values. So you can even look now at the graph. Okay, what we're doing is we're talking about this graph right here. That's for 2a. Everything shifts to the right 3 times. Okay, the y values don't change. Don't go up, don't go down. Just shift everything to the right 3 times. And if you look at the original points, your x value on the original is a 0. So add 3, that's going to be a brand new 3. Then you have an original x of 1, add 3, that's going to be 4. An original x of 3, add 3, that's going to be 6. So you can see that's what we're doing is we're just shifting everything down to the right 3 times. All right, now reflect over the x. We're looking at 2b. And if you're tracking with me, guys, we're on page 60 right now. Reflect over the x, just so we remember what that means. Reflect over the x means only change the y. Do not change the x. So now let's take a look. Now look at the red points that are underneath those green. Now those come into play. Those are for the 2b problem. Notice how every x is still the same, but every y value is now the opposite. Like if it was a positive 2, you'll see now it's a negative 2. 0, that's great. That never changes. If it was a positive 3, you'll see for our very last point, positive 3 for y flips, changes to a negative 3. Okay, so when you reflect it, you are doing the perfect opposite of what we were given. All right, so we reflect, we have a brand new graph there, and we take that checkpoint and we flipped it. All right, just went right over the x-axis. Okay, perfect. By the way, we are going to be heavily using that chart, stretch and compress, on page 61. You need to have that in your notes. That's going to be very important, I can tell you right now. So use this chart, and this is our last example problem right here. Original graph, still the same, still got that checkpoint. The V shape, again, green points, those are still original. And the last problem here says it's a vertical stretch factor of 2. A note that I want you to add, anything vertical changes the y. So I will be adding that note off to the side here. Okay, so vertical change y, and then the horizontal, sorry, losing some space there. We are only changing x for that part. Sorry, I know it's kind of crunched in, but vertical stretch or vertical compression, you're only changing y. A horizontal stretch or horizontal compression, you're only changing x. All right, so now look back at the original problem. It's a vertical stretch, meaning we're only changing the y, and it's a factor of 2. Take every y value and multiply them by 2. All right, so that way we can fully see it here. Again, those points in green are the original. Don't change the x. Every x value stays the same. Every y value multiplied by 2. So 2 times 2, that's how we got 0, 4. 1, 0, that's great. That does not change. By the way, you see those VS's next to it? It stands for vertical stretch. And then the 3, 3 is the original. Multiply y by 2 creates a new point of 3, 6. And then you can see the graph there. That's already been regraphed. That basically is pretty easy to see, that you take the original graph and you stretch it. Okay. All right. That's all I got for you guys. That takes everything that should have been in the first video. My apologies, whatever reason didn't work. And now that's in our second video. All right. Miss you guys. Hope you're doing well. See you in the next one.